talking about network. Once again, I welcome you to today's class. Now, these are the things we are going to learn. Now, I sent a material, that's like a book that we actually meant to read before now. With the assumption that we've actually gone through that book, I'm going to go through this step by step, putting in some questions along the line. So now let's start with network topologies. Now, there are some things that you may not really need that much, whereas there are some things that you would need, like they're like our major area of focus, and there's some things that I'm going to skip simply because they've been explained fully well in the textbook. Before I proceed, please, Christiana, confirm if you can hear me loud and clear, and also you can see my screen.
Good afternoon, everybody. Yes, I can see your screen and I can hear you clearly.
Okay, thank you very much. Okay, now let's continue. Topology basically is talking about the arrangement of different endpoint devices. Yeah, in a network. Network is when you connect. I'm just explaining it in like a layman's term, in the simplest way as possible. Connect one device to another device, and so on and so forth. So before we proceed, I made mention of something. I said endpoint devices. What do I mean by endpoint devices? Just somebody just raise up your hand. I call you, then we move on. Make it quick. Endpoint devices. Anybody? Anybody? Okay, Hilary, let's hear from you. What are endpoint devices?
Endpoint devices are equipment like systems, laptop, desktop, printers, even IP phones connected to the network.
Exactly. Thank you very much for that quick answer. So he's correct. Endpoint devices are just like he said. Let me see those devices that are like at the receiving end of a particular network. You see where the name comes from. Endpoint. I think I've told you that if you want to know the meaning of some, let me say, big words or some complex words in cybersecurity, you can easily break it down. Break it down, get the root word. By the time you get the root word, you will know the meaning. Take, for example, they say something like malware. You break it down, you have something like malicious software. From there, you can already know the meaning. So endpoint also, the devices that are actually at the receiving end of network. Now, moving forward, the need for networks and network components. Now, the internet is short for interconnected network. We need hardware to interconnect computers. Now, let's move forward because we have a good number of pages on this slide. We already know what network is. Connecting one device with another device. Now, when they are being connected, information is actually being shared between those devices. If you've gone through that CCNA book well, that's where they made mention of something like packets of frames. Now, when information is like transmitted from one device to another device, let's say from a PC to another PC or a phone, they're always like transmitted in the form of packets. Now, all these packets can actually be intercepted, analyzed, or whatever it is you want to do with them. Now, there are different types of network depending on the size and scale of the group of communicating system. We have LAN. That's the one that we are always conversant with. Okay, the one that we are very, very much conversant with is PAN. PAN is personal area network. Say like your Bluetooth connection. Let me say your phone to your AirPod, your phone to your wrist watch. That's your Apple Watch, iWatch here. So moving ahead, we have LAN, local area network. You must have seen something like this in elementary computer science in secondary school. Then we have WAN, then we have the internet. I think internet, and we can also call it like GAN, that's global area network. Now, different examples of LAN. LAN is local area network. If you are dealing with cybersecurity, like the main, nobody will ask you for a definition of LAN, but it's always ideal you know the meaning of LAN, which is like local area network. So a simple scenario is, take for example an internet cable which connects the cable modem to the wireless access point. Then even other devices in your home. Let's say you have a Wi-Fi, then different devices are connected to that Wi-Fi. Not necessarily Wi-Fi, it could be a router. Now, so many devices are connected to it. Even your, let's say your television set, your phone, your sibling's phone, your parents' phone, they're all connected to it. Let's say it's like an office. We have the printers, computers connected to like a wireless access point. That's LAN we are talking about. Now, talking about the network components is actually very, very important to know this one as well. We have network interface card. It's always like in your PC. Now, it connects a single computer to a switch. Like I said, look at what is on the screen. NICs are part of computers and other connected systems and allow wired or wireless digital communications with other devices. Tomorrow, where we'll be dealing with the practical aspects, we are going to be working with Wireshark and at the same time we'll be working with Nmap. Yes, we'll be talking about Wireshark and also Nmap. In your in your Kali, if you load up your Kali, let me share my screen so you can see Kali as it's loaded. Then I'm going to show you Wireshark, and at the same time, I will show you Nmap, the way both of them, the way they look like, just like talking about their interface alone. But before we do that, let's just proceed with this. Now, I just told you about NIC, Network Interface Card. So we have switch also. Switch, I'm not talking about the switch that you have in your house, like on and off. No, there's like a networking device that they call switch. It connects multiple networking devices inside a single LAN. Same way you have switch, you have router. Now, example of wide area network. You can actually go through this. You can go through this because they are actually given to you in that CCNA material. The material I sent earlier on. Now, wired versus wireless network. This is one juicy part. Wired versus wireless network. Now, let's really talk about wired. Wired network, that's higher bandwidth. What I mean by bandwidth is just use this understanding of width. Take, for example, now, they're asking you for the width of a rectangle. Somebody is saying this rectangle has a larger width compared to this rectangle. I'm sure you know that this one rectangle is bigger than the other one. So the same way they are saying for this wired network, one has like a higher bandwidth. One has like a higher bandwidth, meaning it can actually accommodate more traffic. That's faster upload and download speed. That you can see, it can accommodate more traffic since it is wired. It basically is using cable. So it is not subject to interference by other wireless devices. You know what I mean? Because let's say you want to connect a computer to another, let's just say a computer to a phone, and you've connected them with a cord. Cord is the wired device here. By so doing, interference cannot happen. Like there can't be any kind of interference. Yep. So now the cost of installation is high due to routing of cables and the likes of them. So it is less flexible and costlier to maintain. But then look at wireless network. Wireless network is the one that we are very, very familiar. We should be familiar with both of them, but then wireless network, take for example, now you want to connect to, the way you're connected to the internet is wireless. The way you're connected to your Wi-Fi or your, let's say someone puts on hotspots, the way you're connected to it is also wireless. Cheaper and easy to install, generally cheaper to maintain, extremely flexible, lower bandwidth. You can't compare. Let's say you are sending something from your laptop to your phone with, let's say you're sending a video with code. Then you are sending that same video another laptop with, let me say, Zender, that's wireless. You discover that the one that you are using code for is going to be faster than the one that you're using Zender, that's wireless, is going to be faster than it. Yeah. So moving further, history of the internet, which we can read it up online. We can read it up online, not online, or maybe using the material, or any means we want to use, we can always use it. Now, network security devices. Network security devices. The various network security devices we have firewall. What does firewall do? Now, before I give my own explanation, I'm going to ask somebody, what can you say about a firewall? And I'm going to now break it down in such a way that you're going to understand it properly. Anybody, what can you say about a firewall? Okay. Mba, what can you say about a firewall?
Okay. Can you hear me?
Yes, I can.
Yes, I can. Okay, I can say that a firewall provides a kind of a barrier between two networks. It can be software based or hardware based. So it provides a barrier that filters out unwanted devices or network connected on the network itself.
All right, that's great. Thank you very much for that. Now, just like what he said is perfectly correct, as 100%. Now, look at it from this perspective. Via this way, you understand it properly. Let's say we have a building, and in that building, um, there's like conflagration, or how do I call it? Like fire outburst or fire outbreak. Now, basically, the idea of a firewall is to prevent the encroachment of that fire into other sides of the building. That's where the idea is coming from. You get, you're kind of trying to prevent the extension or the expansion of a danger. Danger has been spotted. Then if that's basically where the idea comes from. Now let's bring it to networking. Firewall is basically that networking device that helps to block malicious, not necessarily malicious in this case. Sorry, I'm using the word malicious, but not necessarily malicious. Let's use the word unwanted. Yes, unwanted network from coming through. Now, the unwanted network I'm talking about could be IPs. It could be IP address. Okay, we've not talked about this thing. We've not talked about Nmap. When we're talking about Nmap, I'm going to make mention. I'll make mention of this thing I'm talking about now. I'll make mention of this firewall now. I'll say it again. Yeah. So basically, that's what it does. Like, you ward off unwanted this thing. If they spot my IP, let's say my IP is 192.168.0.2. Once the moment they spot it and they flag it as red, that's like it's bad. Is unwanted. The moment it's being spotted, the firewall will prevent that particular IP from accessing the network. So that way, firewall. So you can say that I'm spending more time on the security device because our major area of emphasis is security device, that network security. But then, before you deal with network security, you need to know network itself. So moving further, what do we have? Okay. Sorry, 1 minute. I'm trying to load up Wireshark because I'm going to show you Wireshark, but I'm just going to show you I'm going to give like a glance through it. Tomorrow we are going to deal with the practical aspect properly. Wireshark, we'll deal with Wireshark, we'll deal with Nmap, and we'll use Cisco packet tracer to just exemplify how networking devices can be interconnected, right? Yeah, so that's what we are going to do. But for today, we are going to just treat them like in like a glance, like a bit of an tip of an iceberg. I need to say. Okay, let's continue. Now, these are the pictures representing this thing, firewall. You can look at the examples here, anyways. All these are theoretical aspects. Firewall, you can look at the example, like the different types, sorry, not example. So the way we have IDS, that's the way we have IPS. IDS is the intrusion detection system, IPS is the intrusion prevention system. Right. Sorry, please. Good. Now, this is it. Firewall and IDS. A network firewall sits in line so that they can block traffic if necessary. Remember I said unwanted. You don't block unwanted. Unwanted, it could be IPs, it could be whatever it is. Let's say this is the internal network. Let's say network in your house. Let's say you have a network of your phone, your PC, your family member's PC, then the printer in your house, then your television set, your refrigerator. That's if it is okay, let us use a refrigerator. Let's say you have CCTV camera installed in your house. When all those things are interconnected, we can call that your internal network. Now, if you don't want external traffic from penetrating just anyhow, you can only permit the IPs of those different devices to pass through this network firewall. Any other thing, you can just blacklist it. Right? Now, what you are going to do is the process of enlisting those IPs that has to do with your internal network is called whitelisting. So you put all those ones can go to and fro and go to the internet, then come back. But the moment it wants to see, the moment like an unwanted IP is passing through, it will not allow. Now, a similar thing happens to IDS, but in a different way. IDS usually observe, but they don't block traffic. So the moment they've spotted, like, let me say, a flagged IP, probably an IP address. We all know what IP addresses are. Anyways, if we don't know, I would like put us through down. The moment it flags it, then it can be analyzed by, let me say, a security analyst, probably when they are doing investigation or whatever it is they are doing. Network addressing and port numbers. So now, basically, this one is of interest to cybersecurity. Let me use the word cybersecurity. Now, you want to do something, it goes through a port. What's a port? Just like now, use the word portal. For those of us that actually went through, let me say, higher institution, you discover that each institution has like a portal. That's like, let me use the word an opening, whereby you can actually peruse through to see what your course content, your grade, and different kind of things. Just like a door whereby you can enter, you and the university can actually communicate. I'm not talking about you and your lecturer. That's like a port. That's like let me say an entrance or a gateway or a passage through which you and the university can communicate. You've written test, university will now tell you, hello, for this particular course, this is your grade A. Now, that's where the idea of port is coming in. Now, how did we come about port number? Due to the fact that we have so many ports, alternatively, we also have port numbers. Now, we have over 535 ports, and as we have those ports, we also have different port numbers assigned to them. Let's look at what we have here. Now, basically, the example here is talking about the different the aspect of network addressing and port numbers. Now, you want to stream a movie on your computer, how does the video from the remote streaming video server reach only your computer and not, let's say, your neighbors? Every computer on the internet must have a unique address. Every computer on the internet must have a unique address. Now, I want everybody to follow me. Let's do something. If you have your PC with you, press the Windows key. When you press the Windows key, press CMD, then you press enter. Press the Windows key, you press CMD, then you press enter. You should be seeing something like this on the screen. I'm going to show you now. So how many of you can see this? Christiana, please let me confirm if you can see what I have on the screen. That's my terminal.
Oh yes, I can. I can see
Okay,
it.
thank you very much. Okay, now if you have your PC with you, you can do the same. How do you do it? Press your Windows key, then you press CMD. You can also call it terminal if you want to call it terminal. Now, what's the last line I said? Last line I said is every computer on the internet must have a unique address. Let's come and check here. So what do we press here? We press IP config. That's like a command. IP config is a command. The command is to give us the different IP configurations or the different like internet protocol addresses associated with my PC. I press enter. Then you can see the different things coming out or showing forth in my PC. Now, look at, just take note of this. Take note of this. Let's start from the beginning. Let's take note of this. Ethernet adapter, Ethernet 2. The same media state, media disconnected. Why is it disconnected? Because there's no Ethernet cable connected to my PC. Wireless LAN, forget about this one. LAN adapter. There's no wireless LAN adapter connected to my PC. All these ones, you can just forget about them. We don't have them connected to my PC. We have Ethernet adapter, VMware network adapter. That's my VMware that is actually currently loaded. So these are the IPs associated with my VMware. Now let's quickly go to VMware and see what is there. Please follow me. I'm coming. We're going to come back to this. Good. Now going to my VMware. This is my Kali. Let's open that same thing that we opened in. Should I just share my entire screen? So this is our terminal. You see this black thing here is our terminal. We're going to explain it properly in the class. We'll explain it properly. Okay, let me be very sure. Please, Christiana, confirm if my screen has changed. It should be Kali that you are seeing.
Yes, it is.
Okay, all right, thank you. So now going to that Kali. Now let's check out our let's check for that same thing. But this time around, I'm using if config. The other one I used IP config. Now I'm using if config. Now, what is the IP address? What is it telling us? 192.168.195.130. 192.168.195.130. We can see that, right? Now, coming back here, navigating through all these things. Now you can see the subnet mask. 255.255.255.0. So basically, this is my subnet mask. This is my IP address. This is my IP address 192.168.195.130 for my VMware, right? So now let's go back to, that's just for VMware. That's for Kali, I mean to say. You want to get the address. Now let's go back to our let me see if I can share the entire screen. Okay. Good. Now, coming back to my command prompt, you can see the IP address. Now, this is our major area of concern. You see this wireless LAN adapter Wi-Fi 2. My laptop is currently connected to a Wi-Fi, and this is the IP address. This IPv4 is what we are going. I'll talk about IPv4 and IPv6 later. Although it's expected that we've read about it, but then I'll still talk about it. So this IPv4, this is the IP address associated with the PC 172.20.10.2. This is subnet mask 255.255.255.24c. Then the default gateway. So the reason for showing you this is to like tell you that each computer that is connected to the internet has like a unique address associated with it. So this is like the IPv6. I'll talk about the IPv6. I'll talk about the IPv4 later in this like class. So let's proceed. I just want to like show you that okay, these guys actually have their unique identity. This is what you can, instead of calling somebody Jide, or calling somebody Shola, or calling someone Mohammed, or calling someone Musa. For my PC now, in the internet space, this is actually the name you can actually refer to my PC. Moving forward, we have this. All right. So now, next issue is we love to multitask here. Yeah? We tend to browse the internet, stream videos, chat with friends, check the weather on an app, all at the same time. How does the video streaming service send the video to the streaming software on your computer and not the chat software? How does the website data you are browsing get to the browser instead of the weather app? Now, what is the answer? Network addressing must also uniquely address individual applications. This is done through port numbers. Now, what are port numbers? Like I said, we have ports and we have the different identities for each port. So we call it like what? We call it port number. Let's proceed. Now, every computer on the internet has a unique internet address, which is what's called IP, which I just showed you, IP address. The IP address is 32 bits long and has the format A.B.C.D. Each letter is a number between 0 to 255. A typical example is 137.45.192.100. That's a valid internet address. Now, every network application on the computer has a unique port number. Port numbers disambiguate the addressing of network applications where multiple applications are running on the same computer. What I'm trying to say is that port number is going to like ensure that this particular application is different, entirely different from this one. So it's not going to like be it's not going to mix them up. Despite the fact that both of them are working at the same time. Let's say I have my YouTube running at the same time as I'm making this call with you. So the different port numbers will actually like differentiate them Now, for example, web servers are usually assigned port number 80 so as to reach the web server at the internet address this. So we must address our network data to both the internet address and the port number using this notation 137.45.192.110 colon 80. This colon 80 is the what? Is the port number. Colon 80 is the what? Is the port number. Now let's check the internet and check various services and their port number. Remember I said they are over what? 65,535. I think it's 65,535. I'm not really sure in this. So sorry about this. So we have various ports and their respective port numbers. Like I said, we have over 65,000. Now, these are the popular ones that we have. Let's just jump through here. Now, ports 20 and 21, they are for FTP, file transfer protocol. So you are talking about transferring of files. We are dealing with port 20 or port 21 FTP. Could be TCP, could be UDP. Port 22 is for secure shell. So you want to connect to like a machine virtually. You want to use shell, I mean to say, connect to a machine. That's where the secure shell comes in, and you are going to understand this more when we're talking about like some very popular attacks when we are using Metasploit. Now, port 25 is what? SMCP. Port 25 is what? SMCP. Now, simple mail transfer protocol is, let's say, like as the name implies, for mail transfer. So port 53 DNS, 80 HTTP, 123 is NTP. Then 443 is not written here, it's for HTTPS. That one I just mentioned 443 because it's popular. You see this thing I did here. Look at this, my this query bar. I don't know if there's a name for it, query bar or something. Whenever I type anything, let me see, I type hello world. If I type go, it's going to like send like a get request to the server. Now what's it doing basically? It's actually running on port 443. And what does 443 mean? That's HTTPS. Now, what's the implication of this? What does it imply? Let's go back to this. What does it imply? Now see, what does it imply? Let's say you are a cybersecurity engineer and you are hired to work for a company. You are just hired, not really for a company. You are hired for a contract job. You have to like look for the vulnerability in a particular system. The first thing to do is to perform what they call reconnaissance. Reconnaissance means gathering of information. You are gathering plenty of information. Now, what does that mean? What does that tell you? Or how do you go about it? The first thing is what you run your Nmap. You run like an Nmap scan. From the Nmap scan, it's going to give you like the various port numbers that are open. Now, what does that port number tell you? It's trying to tell you that this company's system is running this kind of services. From there, you can know how to proceed. I don't know if I'm making any sense. Okay, let's continue. Now, this port number explained in details. So now we have networking address. Networking address. So let me break this video for the sake of simplicity.